Vaisala, in particular, WX Horizon and Road AI. So, Eric and Nicole, would you like to introduce yourselves um, and let us know who you are, and then we'll dive in.
Yeah, sure. So I'm Nicole Parker. I've been with Vaisala for about 3 years now, specifically working with a product called Road AI and WX Horizon. So yeah, have just been working with public works departments and kind of helping them make their road maintenance practices more efficient and effective. And I'm excited to talk about that today. Eric?
Awesome.
Yep. Thanks, Nicole. Hi, everyone. Thanks for joining today. My name's Eric Faulkner. I'm basically Nicole's counterpart in Vaisala X Weather Roads. I'm a meteorologist, so I focus a little bit more on the weather side, but still focusing on both WX Horizon and Road AI. I actually live in Charleston, South Carolina on the East Coast, and I've been with Vaisala for about the same amount of time, around 3 years as Nicole.
Awesome. Well, thank you both for joining us. It's, when you're talking about infrastructure and the weather and things like that, current events can definitely catch up with you in a big hurry. And we saw with the flooding over July 4th and the flooding today, I think, in New Mexico, that this time of year, unfortunately, flash floods are a major issue. So, with that, we have a poll that I would like to launch for you all. And the first part of the poll is this: what percentage of your infrastructure has been severely impacted by weather over the past 2 years? And it's less than 10, more than 25, 50, or more than 75. So if you would like or care to give us that sort of information, that would be good. I think these things are, weather is weather, and we all have weather to live with. And we do our very best to make sure infrastructure is geared to the weather we're going to deal with. But we're also seeing these, I don't want to be in any way apocalyptic about things, but possibly because we have more infrastructure, we tend to see more impact uh, of weather on that infrastructure. So it's interesting to get a sense of where we're going on that. And we've got some. There are other questions which I'm sure you're discovering, and then there's some short answers looking for that biggest pain point in your um, area. So, and we have nearly 70% of you have responded, so thank you for that. We'll give you a little more time to do
And it,
that.
it could be interesting if you put in the short answer too, like where you're from, what area, because all regions are going to be different, obviously, in the type of weather that you all see. So
Yeah,
if you haven't answered number three yet, if you could just put where you're from.
yeah, that's awesome. Very good point. And we'll not hang around on this much longer. Not to put pressure on you or anything, but
Start playing the Jeopardy tune.
yeah, yeah. If we want any music, you're sadly left with me, which is not a good choice. Me and my musical abilities fall way, way low on the scale of capabilities. So, um, and I think we're at the point where I think we are probably as close as we're going to get to everyone participating. So I will wrap that up. And we can go ahead and share those results. Well, which hopefully people can see. A plurality of you have less than 10% of your infrastructure, and only one of you had more than 75%. most of you, city, county, or equivalent government entity with a vendor and academia there, and nobody falling into that interesting some other entity capability. And we got some, let's see if we get those details. Insurance, parking, potential for bureaucracy, slowing down a large-scale response, and dealing with slides. Now that's interesting. So yeah, we'll okay, just get rid of that. Put that away. We've done our poll. I'm going to stop my sharing now. And Nicole, you mentioned you had some slides you want to take us through. That'd be awesome if you could do that.
We'll share. Oh, I need to send a request.
Okay, yeah, I'm letting you.
All right. Let me get my scoring up. All right. Can you see my screen?
It tells me yes.
Yep, we got it.
Great. And let me just go here. All right. So yeah, so while we go through this fireside chat, just want you to kind of think about, you know, are your assets prepared for the next weather event? So think about where you guys are geographically, what has gone on in your area, as recently as this past year, what your budget allocates for unexpected events. And I know somebody kind of mentioned in that short answer that bureaucracy is kind of a big thing when it comes to, or kind of just deploying resources at a short amount of time. So that's interesting. And then what climate trends are you seeing over the past 5 years? And the reason why I say that is because the weather is always changing, and it is either getting more extreme rather than less extreme as we go on. So yeah. So the challenge here that we'll basically talk about is the infrastructure that's being at risk. So we all know that extreme weather events are becoming more frequent and intense. So many assets such as roads, bridges, utilities are often aging and very vulnerable. So we know reactive maintenance is really costly and often comes too late, leading to service disruptions, financial strain. The need for proactive data-driven management has never been more urgent. So we'll talk about a few solutions today. So I took this kind of stat from 2019. There is ever increasingly maintenance costs. So across 24 states, so over half, under half, North America, in 2019, we spent about $1.2 billion over damages. So based on the disasters we're seeing today, it can only get more worse as we sit back and react to the unpredictable climate. So some real life examples, there were actually 2 just last month. I'm sure you guys all saw the Missouri road buckling from extreme heat that destroyed 2 roads in Cape Girardeau. And then upper Midwest kind of experienced devastating river flooding with record-breaking rain. Just in September 2024, Hurricane Helene destroyed a lot of rural areas in North Carolina and Tennessee. And this was kind of devastating, especially for those rural areas because they have less resources. And then as far back as February 2021, Texas experienced a major power crisis from a deep freeze that impacted the entire state, causing power outages and record-breaking damage. So these are kind of the examples that we're just kind of seeing more often, unfortunately. And we're going to kind of try and help you prevent that with the power of data. So this is kind of the potential solution here. The good news is that data can transform how we manage assets. So by integrating real-time sensor data, AI, and computer vision, which we'll talk a little bit more about a solution we have As well, we can proactively identify risks and vulnerabilities and make informed decisions. And again, really focusing on that data-driven maintenance strategies. So this approach helps us move from reactive repairs to predictive maintenance, saving time and money. So let's talk about these two solutions. So I'll introduce Road AI and I'll then pass it off to Eric to introduce WX Horizon. So Road AI uses computer vision, which is a type of AI, to provide detailed and automated assessments of road conditions. So this solution is positioned to replace the manual windshield survey. There's a lot of technology out there that is doing this, but specifically, we wanted to not get into the asset management space and really just impact the time it takes to manually survey your roads. We wanted to be a lot more objective. So by putting a cell phone on any vehicle that's out on the network already, and the key here is kind of that environmental and safety measure of just putting it in a vehicle that's already out on the network, driving around your network, and then you get that data within a couple of hours. And when I say data, I mean pavement condition, defects on the road, certain signs, or mostly all the MUTCD signs we have detected, as well as certain assets such as guardrails, and as well surface markings and line markings.
So Nicole,
yeah,
can I, quick question there.
Yeah.
Actually, two things. First, if anyone has questions about any of this, please put it in the Q&A. But secondly, just so I'm clear, what you're saying is when your garbage trucks are out, if you have a cell phone in your garbage trucks, it can be gathering that data for you.
Yeah,
Or even
exactly.
on your transit fleet or any vehicle that is out there can be getting this data for you. Am I correct in that?
Exactly. And usually you have, again, we have a lot of cities and municipalities on this call. You do have vehicles out on the road anyway, like utility trucks going out often. So you can put it in there and just take a drive around your network. It's pretty, you don't need to like touch the phone in any way. You just press record and you go. So it's very straightforward, very user friendly. And when it comes to kind of how many municipalities are using this, we have about 300 worldwide, but we have about 60 in North America using this as well. And they're kind of all spread out in North America. So it's kind of been interesting to see the real-time effects and kind of what features within Road AI are being most commonly used. So I'll save that for our kind of real stories from clients, but I'll pass it over to Eric to talk about WX Horizon.
Yeah, so WX Horizon is more on the winter side, on the weather side of things, primarily used for winter maintenance to help with snow and ice removal. So it's a hybrid system. And what that means is not only is it providing the forecast, like you see in many of the weather apps or your local news stations or any of those sources, but it's also providing you with real-time data coming directly from your roads utilizing road sensors. So we combine them both. And the reason we do that is you can get your real-time data, but then you can get far more localized and accurate forecasts directly on your road network. So that's really the key there in getting the best information possible. Nicole mentioned it already. With the weather, we can't stop it, obviously. We can't change it. We can't alter it. But at the same time, we can prepare for it as much as we possibly can. So in order to do that, having highly localized data allows that forecast to be much more accurate for you to be able to prepare and have a little bit more trust in preparing ahead of time. So that's the basis of WX Horizon. But at the same time, too, we've been doing a little bit more, and we'll show you some examples of this in the slide deck, off season, outside of winter season, and how it can be utilized there.
Yeah, so a little bit more kind of going back to the problem that we're talking about, kind of infrastructure at risk. So why choose these solutions? So together we deliver a range of benefits. So proactive monitoring, so utilizing advanced sensor data to predict and mitigate risks, so the pavement temperature, but also defect data. And then early intervention, I'll talk about a theory that's used by the FHWA that's buried on their website a little bit later. But basically spotting vulnerabilities early before they escalate can have really big savings in not only time, but money. So again, cost efficiency, saving resources by maintaining assets at optimal conditions. Again, talking about that theory. And then comprehensive insight. So leveraging computer vision and AI to make informed decisions and enhance resilience. So what is that theory? It's probably my favorite theory in the entire world of transportation, but it is buried on the FHWA website. It was born in 2013, but it basically says if you detect defects, and specifically out on the road, earlier on in the deterioration cycle, and I'm hoping some of my engineers on this call know what I'm talking about. If you detect defects earlier on in the deterioration cycle, so catch them between good and fair, instead of letting them get all the way down to 0, where you have to do like a full overlay, you're actually going to spend less on maintenance costs. So Road AI specifically kind of enables you to go out more often and survey your roads. So I'm not saying like you have to go out every day now, but we enable you with a set allocated hours per year to go out, before and after storms come through, before and after maintenance has been done. And we have a few examples that we'll talk about later. But basically, we're trying to save you money in terms of going out more often to catch those defects earlier in that deterioration cycle. So real live stories. So the most used feature of Road AI is actually not computer vision analysis, which is very surprising. It's obviously still used, and it's super cool. But the video feature of Road AI is where towns, cities, and counties can see the before and after effects of weather by going out and driving the roads to see that climate impact of assets and road infrastructure. So I have a few examples here, and then I'll talk about some that aren't on this list, but Road AI specifically can help identify areas of flooding that need to be taken care of before and after storms. So a county in New York kind of went around before a storm came through and identified areas of flooding that were already kind of being built up on bridges specifically, and could really cause havoc, especially if people are traveling, trying to get out, and create a lot more of an emergency. We have a few examples. We had 2 Tennessee counties using us before Hurricane Helene came through, and they were able to pinpoint their weakest roads, and were able to do as much work as they could before the storm hit. And these were really rural counties. So they were able to kind of triage, be able to have multiple vehicles out in the network if they could, to really get a lot of road data. And the result was less catastrophe on rural roads because they pinpointed those vulnerable areas sooner. And then this is not climate related, but kind of. This was interesting. A wind farm was being built in a rural area of New York, and a lot of trucks came through with heavy material, and the roads were absolutely destroyed. The county did not know that they were coming through, but they were able to get before and after effects of the roads through the video, and were able to kind of allocate with the city council and legislature for more budget allocation for these roads. But it was definitely telling, because video can't lie in any way, and the data can't lie when it comes to pavement condition. You could obviously see that big difference of the roads being damaged. So yeah, so I think oh, sorry, that was a video that was supposed to be playing the whole entire time, but I'll let Eric go.
I didn't realize video worked in this. It's good.
Oh, it did. Okay, cool. Great. Yeah, so real world impacts for WX Horizon. And don't worry, we won't talk about winter because we're in the dead of summer.
Yeah, like I mentioned, this is primarily a winter service, but there are some applications during the off season, particularly in summer. So this really goes back to kind of the severity of impacts across your road network and your infrastructure. And it's really a relative, but it was interesting to see the answers because it is kind of relative. It also depends on the types of weather events and things like that. But one thing people don't really think of too much, and I don't know, maybe you all do, but heat and the damage that heat can cause, particularly on the road surface. So I just put some stats in here that many of you all may know, but pavement buckling occurs when the pavement expands due to heat, especially the crack or joint as the sides are pushing together. So they push together, that causes the road to buckle, causes major issues on the surface of the road. So the roadways are most vulnerable typically when the temperatures push 100 degrees. I mean, they start to get vulnerable when it's 90 or above, but once they get to 100, then they become more vulnerable to this type of issue. And they typically occur on older or weaker surfaces. So as Nicole was saying, with the information, the data that can be collected through Road AI, you can understand which surfaces are older or potentially weaker, or there's more distresses on that surface to get a good determination on if these roads are potentially at risk during summertime heat. And then one other stat, asphalt begins to soften or melt around 120 degrees, becoming more susceptible to damage. And that's not air temperature. Not many places see 120-degree air temperatures unless you're down in the deserts of Arizona and California. But that's just road temperature. So if road temperature exceeds 120 on an asphalt surface, asphalt does begin to soften. So you have cars driving over it. Obviously, that's going to cause depressions and things like that. So one of the most important things to then try to understand which areas or which roadways are most at risk is having road temperature observations and forecasts through the use of road weather sensors. And on this map, what you can see here is just kind of a general idea of road weather sensors across the United States that are our network at least, and what those road temperatures were at this particular screenshot. So again, you can see different areas where they're much warmer than others down there at the Gulf Coast. Road temps in this specific point in time were over 140 degrees Fahrenheit. So that's really, really hot on the road surface. Nicole, you can go to the next slide. So real world impact. We talk about this again. We talk about this a lot from a winter maintenance perspective, with having road temperatures and things like that, so you can understand, when to send out crews, when to put treatment down. But at the same time, there's also an impact with the roads getting hot or the temperatures getting elevated on the other side and getting too hot, and understanding the potential for damages and even other things like crew safety. So it really is something that can be used year round. I have here which roads are most susceptible over time. If you have sensors scattered across your roadways, you can understand what the temperatures are in different areas. Some areas might be warmer due to the type of surface, due to potential shading, due to more traffic, things like that. Some areas might be colder. It really just depends. And I mentioned the crew safety thing. So this example is kind of like, if you ever watched, college football or any football, and it's right at the beginning of the season, they always have the thermometer down at the field level because they're like, oh, the temperature is 95 degrees outside, but down here at field level, it's 120. That's because the artificial turf generates heat and absorbs heat. So that's the same with the roadway. Just because the air temperature is 95 doesn't mean right above the surface of the road it's going to be 95. It's going to be much, much hotter. And that's an issue with crew safety as well, because it could be 120, 130, and that causes all kinds of problems with needing to hydrate and everything like that. So it's important to understand the temperature of the surface of the road so that you can understand what the potential temperature is just above that surface of the roadway. And then the Cape Girardeau example from Missouri, which was if you saw the video, it's kind of like Dukes of Hazzard, the car completely flying over the runway because it buckled right in front of them. I'm sure that was terrifying. So how hot were the road temps in that scenario? Well, unfortunately, we don't have sensors in the Cape Girardeau area, so I can't give you an exact road temperature. But we do have sensors in Missouri, and you probably can't see the actual values. I should have made these screenshots a little bit bigger, but this was June 22nd when that video was taken in Cape Girardeau. And in the Kansas City area, there were a few sensors exceeding that 140-degree Fahrenheit mark. So that heat wave impacted a large region. I'm assuming road temperatures were probably just as hot, if not a little bit hotter, down there in Cape Girardeau during that time, which obviously led to that specific roadway buckling. And then I have another screenshot down here over toward the East Coast. This was in the DC area where we have a number of sensors across Northern Virginia. And I think this was their hottest day, or one of their hottest days, June 24th, where I think the air temperature was around 100 degrees. Road temps here at that time at mid-afternoon on June 24th, some areas were exceeding 150. So that just gives you an indication of how hot the roads can get and the type of damage that can be caused due to the heat. But then again, you can see kind of a thermal profile as well, because some areas weren't as hot as the ones that had reached 150.
I think it's also important to note, like you kind of mentioned this with crew safety, Eric, but I know City of Independence in Missouri uses this to basically call out if they shouldn't do road maintenance work at all because the asphalt is too hot and also will melt, and also they won't be able to really fix anything. So they kind of use this as their stopper to not do construction work. And obviously summer is high time for construction work, so they want to protect their crew as much as possible, but also not waste time in terms of putting down hot asphalt if it'll just kind of melt or whatnot. So
yeah, there could be an issue with spreading, but also like you mentioned, the crews, they don't want anybody passing out or having health issues because of the heat. I'm assuming most of you on the call, that's the last thing you want to happen to your crews.
So, Eric, Nicole, we've had a question come in saying, do you work with AVLS providers to integrate this weather information into their platforms? In other words, if you have trucks out, can you let those trucks know when they are close to areas of particularly high temperature?
Short answer is yes. I mean, without knowing the provider of the system, I can't give a concrete answer, but short answer would be yes. This data is able to be downloaded and extracted and ingested into other systems. It really just depends on the provider, the types of formats they work with, and if we're able to work with those formats.
Yeah. Now, I think that the safety one is a big factor. There is a lot of interest in a number of areas about this issue of heat exhaustion when it comes to work crews. Often it's in enclosed spaces, which is not what we're dealing with on the roadway, but nonetheless, when folks are out there on the roadway, as you say, Eric, it's not a good thing if people start passing out from the heat. So
generally not.
One last slide. I'll let Eric talk about it a little.
Yeah, so want to say appreciate you all for joining us today. Hopefully that gave you a little bit of insight into the general weather extremes and how they can impact operations and the type of data solutions or some of the type of data solutions that are out there to help you try to mitigate that risk as much as possible. Again, going back to preparedness, can't change it. The only thing we can do is prepare for it. So if you all want to learn a little bit more about either of these solutions, Road AI or WX Horizon, you can feel free to reach out to myself or Nicole, or if you want to reach out to Will can connect you with us. And we'd be happy to talk with you about some of the communities across the country that are utilizing these solutions, how they're utilizing them, and the benefits they're basically seeing from getting access to more data.
Awesome. Thank you. I've got a number of questions I'm going to pepper the two of you with.
Great.
Okay.
Oh,
So, um, beginning with this issue of resilience, resilience has become a sort of very popular word lately, which is good. We want a resilient infrastructure, and I come to think of it in a couple of ways. Way number one is getting your infrastructure so that you avoid any difficulties with, as a result of severe weather. Now that has limits, because yes, I can build a road that is never going to flood,
mm,
but I'm probably going to spend way more money than I have to do that. So then the other aspect of it becomes recovery. How do I design my system? How do I use this data that you are collecting to know what I can do to design my system over time to be more readily recoverable? And I
mm,
guess I'm thinking in some of this, you look, I think in Hurricane Helene, it was Interstate 40 got severely damaged, to the point that basically a number of miles almost totally disappeared. Now, you you can't necessarily avoid that, but how do you build this information into creating a sturdier system, if you will, a more resilient system? So you're getting great data from this.
mm.
Um, what thoughts? What could you do? And I understand this is not necessarily a question with an answer, hence the fireside chat notion here. You know,
Yeah, I think it's for Road AI specifically. I think we find a lot of my customers right now have kind of started Road AI from nothing. So they've not had any data points. They've only done manual surveying. They don't know where any of their signs are. They don't know where any of their assets are. So they're kind of starting from scratch. And then you go year over year, and Road AI kind of has this, I want to say, like blueprint of, City of Independence, for example. But then you could see over time, as City of Independence goes throughout the years, where the roads are being degraded more often than not, and you can pinpoint many factors. It's a major arterial road, right? There's a lot of traffic going through that. So there's ways to, in the system, organize the data by shapefile and kind of what roads are there. So you can just look at your residential data roads. And then over time, kind of see, say, City of Independence has been with us for actually 3 years, so they can see kind of the degradation of the pavement and kind of be more proactive about it. Obviously, we can't, predict Hurricane Helene and that kind of disaster, but you can see
yeah,
the vulnerabilities a little bit more proactively before, say, a citizen comes through and there's a huge pothole or something like that, and you already found that. You already have that data, so you already took care of it or on the way to take care of it. So I think it's just having that data set and kind of building it over time to kind of see those vulnerabilities is going to be the way to build resilience, I would say. That would be
yeah,
my answer, hopefully.
yep,
Yeah, Nicole, and I think one of the things we always say, right, is keeping the good roads good.
Yes.
Like I like that saying. And again, it's not going to prevent every situation. With the
no,
Hurricane Helene situation, you got Interstate 40 on the hillsides collapse because of the amount of moisture. Like no matter how good that roadway structure is, it's probably not going to withstand that type of pressure. However, there are other smaller events, other little weather events that can be extremes, whether that's heat, whether that's flooding, whether that's anything. If you have roads that are traditionally in good shape and you're keeping up with them, they might be able to withstand some of these extremes compared to some of the other roadways, like the Cape Girardeau example from Missouri. I don't know what the state of that road was. I have no idea. But maybe there were already some vulnerabilities in that road, and that's why it buckled with the heat. So it's really about trying to manage your road infrastructure consistently and keeping it as best as possible to avoid some of these issues due to vulnerabilities.
And that raises, as it should, a number of very interesting sort of follow-on questions, which I really I'm going to dig into. If you'll pardon, there is a pun in that. Okay, we'll get to it, because clearly the buckling of the road was not really just to do with the pavement. It was to do with the grade and the subgrade beneath it. And those are things that, if I drive around in, my supervisor's vehicle or my garbage trucks, I'm not necessarily going to be seeing those underground things, but I may be able to infer them from what I can see on the surface. And you talked, Nicole, about creating this database of information. Are there tools, or do you envisage the development of tools that allow people to start dragging out what we might term that subsurface information? I know, and this may tie in, Eric, with some of the
Yeah.
WX Horizon data that is actually subsurface. Um, are there possibilities there? And let's make it even bigger. You mentioned the collapse of the hillside that impacted I-40, and somebody said one of their pain points was landslides.
Yep.
Do we have the potential for digging into those? And I understand these may or may not be things you have right now, but do you see the potential for those sorts of things, or are you in fact way ahead of me? So
Uh, on the flooding side of the landslide topic, I imagine, based on just recent past too, you have Helene, you just had the floods in Texas, and then the floods in New Mexico, and then there's always flooding in a lot of
yeah,
different areas. Those are the ones that have been the most severe and have caused the most casualties, unfortunately. Um, I see the industry looking at ways to. I mean, we've already seen some of this. If you watch the news on the Texas floods, like, why weren't these people aware? Why weren't they getting the alerts? Why weren't they evacuated? Type of thing. I see more of that coming. That's not necessarily an infrastructure resilience thing necessarily. However, that's about safety. So I can see um, more companies and more awareness in the market of trying to do something with flooding. We don't do a whole lot with flooding right now. However, we do a little bit. We have sensors. We can detect rainfall amounts. So let's just go to the Texas example. If we had one of our sensors in the area, we could have detected the intensity of the precipitation, the amount of the precipitation, and then they could have inferred from that on the potential for flooding. Because the problem with the infrastructure currently is, most weather sensors, or the larger networks at least, with NWS and NOAA, are stationed at the airports, which are not stationed at these remote rural areas, and precipitation is very localized, especially with summer thunderstorms. So to have that type of device that can gauge that in real time, I don't know. I don't know if it would give them enough warning or not, but it would at least give them more information than they had prior.
yeah,
Yeah.
yeah,
And I'll say for the subsurface stuff, so with Road AI, we're using a type of AI that is detecting objects through imagery. So
right,
anything that the camera sees, it can see it and detect it, right? So if it's under the surface, it's not going to be able to. However, we are, and I can't say too much about this, but with connected vehicle data, We're actually getting a lot more information from connected vehicles around the network. And this is like not garbage trucks or whatever. It's not a cell phone. It's sensors on a vehicle. And we're collecting third-party IRI data, so surface roughness. And
Yeah.
from that, I feel like that's a better indicator of kind of what's happening below the surface. So integrating that data along with our surface data, I think would be kind of a good mesh. So that's kind of the direction we're heading now.
That's
Yeah,
awesome.
and then like the other thing with subsurface too, so we do, well, if you had mentioned this, with one of our sensors, we do measure subsurface temperature along with the surface temperature. And, some of the conversations I've had recently about infrastructure resilience or just trying to prevent vulnerabilities in the infrastructure or weight restrictions during the springtime when you have the freeze thaw. So
Yeah.
understanding what the subsurface temperature is to help you better understand that freeze thaw and what those weight restrictions should be, when they should apply. A lot of times, and I don't know, what the situation is with everybody on this call and how their community does it, but from the conversations I've had, a lot of times it's really just a blanket restriction over a certain period of months. So you don't have heavy equipment moving across the roadways, and there might be some type of permit that they grant somebody based on a specific project. But if you had a better way to manage that, then you wouldn't have to do a blanket restriction across 3 months if you had the data and understood what those subsurface temperatures were. And then you could continue to have projects going, infrastructure moving without creating damage on the road surface.
Yeah. And that is, again, especially in those rural areas, that can be a major thing. One of the things, Iowa, we have a history of flooding. Thankfully, not like the flash flooding. Ours tends to just be, you get a lot of rainfall and all the rivers rise. But as a result, a few years ago, the state put together what they called the Iowa Flood Center, that measures every single river at multiple points and comes up with predictions for what the heights of those rivers are going to be based on both predicted and measured rainfall. And I'm sure other states have things like that. Do you have methods to tie that into your systems, or is that, and again, pardon the pun, a bridge too far? Um, or do you see that sort of data integration? I'm looking at all this data, and it gets messy. I salivate at all the things you can do with it. Do you envisage the data integration going forward as a possible avenue of development?
There's so many different data sources out there. Some are freely available, some you pay for, but then you have to go to a million different places, right? Like you're saying, well, to get all
Yeah,
that data. Yeah, we're always looking at incorporating new data and integrating that into our systems. Like outside of Road AI and WX Horizon, we do a lot more with weather. Vaisala was founded based on weather instrumentation. So we have our own networks, but we always pull in other data networks if they're available and if they're going to improve um, our product output or our forecast output. So I don't know specifically if that's been looked at, Will, but yes, our team is
yeah,
always looking at new data sources to pull in to be able to provide in kind of a one-stop shop type of thing, or again, more importantly, use to enhance our forecast.
yeah. Awesome.
Yeah. And just on that, like, I want to talk about, like, we got to a point with Road AI where a lot of our customers were saying, this data is great, but I don't know what to do with it. So we never want to get to that point where we're overwhelming the customer with so much data and you can't do anything with it. So it's really important to focus on certain assets that the customer really wants. So like say, for example, signs, they don't have a sign inventory at all. We can help with that. Build that from scratch by just driving around your network and collecting all of that. And then when it comes to getting that data, we don't want to obviously become an asset management system. We want that data to be incorporated into asset management systems so that they can take our data, mesh well with that, and then spit out treatment recommendations or financial models, whatever. So we're kind of on that path of kind of being able to massage the data and communicate with asset management systems. But we also have a lot of customers that don't have asset management systems. So again, with that kind of area of opportunity for us, we're trying to make the data more actionable. So we're calling out, areas of vulnerability much faster, or making them pointed objects on the network like potholes. So kind of acting like an asset management system, but filling that gap of cities and counties that can't afford big asset management systems. So we're definitely a more cost-effective option, but I think it's important to point out that there are times where data can be too much. And it really depends on your community and kind of what's important to you.
So, and on that point, one of the questions with any system, any data source that you get is justifying or presenting a return on investment.
Mm-hmm.
You're going to invest money into getting this system, into collecting this data set and building it over time. What's the return on that? And you've touched, both of you, on various things you can do, but in your experience, what do you see as being the low-hanging fruit? And apologies for the cliche, but it's one we're all familiar with. In terms of ROI, what is the low-hanging fruit?
Nicole, you want to tackle that first for Road AI?
Yeah. So for us, it's mostly, again, we're enabling counties and cities to go out more often and collect this data. So they are catching defects earlier on in that deterioration cycle. So instead of doing a full overlay, we had this one county that came to us and was like, our process is just doing overlays every single year and just spending millions of dollars and not really thinking about it at all. So Road AI came in terms of identifying the roads and kind of getting that baseline, we saw areas where they could just do crack seals or cheaper options to get more life out of the road. So like having a road be just a crack seal can get 10 more years out of that road. So yeah, I think the return on investment is just kind of catching defects earlier on in the deterioration cycle and also saving taxpayer money that is going into just overlaying roads, which costs a lot. So yeah, I would say the more often you collect the data, the more often you're helping our model kind of determine what that degradation cycle looks like year over year. So you're spending less on maintenance procedures.
Yeah, and I'm going to pivot to winter now for WX Horizon. Primarily, that's the primary use case of it. Again, there's some applications we went over that can be kind of tied to Road AI with the heat causing vulnerabilities. But for WX Horizon, really the ROI is all about better managing your road network ahead of time for snow and ice removal. So the main thing that's the most important thing is road temperatures. I mean, that gives you an indication on, do you need to send crews out? Where do you need to send them? How many crews do you need to have on staff? There's so many times once our users started using WX Horizon, they were like, wow, we've sent people out in this exact event before where it's snowing or there's freezing rain in the forecast. And we've salted all these roadways, and then there's no snow accumulation or no freezing rain accumulation. And it's primarily because the road temperatures at that point are 37 degrees, 40 degrees. So the precipitation is melting on contact regardless of if there's salt there or not applied. So we've seen a lot of savings just based on reduction of call-outs, to be honest, and not going out and treating. Really don't need to. That's just one side of it. The other side is also targeting treatments. A lot of communities will use uniform applications, and I think a lot of them still do. and that's fine. That's one way to manage a road network. And it is a little bit more intricate to then go and do targeted treatment. But if you know that this road off to the north east is 40 degrees, but the one down to or off to the northwest is 31 degrees, then you probably want to target that one off to the northwest, spread some salt there. You hold off on the one to the northeast until you have more information. So really, it's just about getting that data and then being able to make more informed, more targeted decisions to see a return there. I mean, some of our customers in one winter season have seen tens of thousands of dollars in savings on salt and labor based on this type of practice with this new data.
Awesome. So, other comments that the two of you would like to make? And before we get into that, we are now at the point where we're beginning to wrap up. I will be sharing some slides again, which means for those of us in the audience, if you have any questions, now is a good time to ask them so that we still have time to answer them. So any closing or near closing comments you'd like to share? I'll give you another chance at the actual end, but.
I just want to reiterate one thing Nicole said about data. It is very, very important to have data because it helps with justification, it helps with decision making. However, you also need to understand what you're going to do with that data. If you have a bunch of data and you don't really know what to do with it, then it's not as valuable to you. So that's where we really try to step into to support and help analyze all of the data that's being collected. But really the first step is if you're not getting access to data today, it's very, very important to try to get access to highly localized data, especially in your area, especially surrounding your infrastructure, because there are microclimates everywhere and the weather models can't pick up on that. The standard networks out there can't pick up on that. That's why we do what we do by implementing these hybrid type of approaches and these sensors out there to collect data directly from your network.
Awesome. Nicole?
That was perfect. That was exactly what I was going to say. So thanks, Eric.
Awesome. Okay, I'll bring my slides up. Just a reminder, this is a Professional Snow Fighters Association webinar, and please visit our website. And if we would love to have you, if you are not already a member, we would love to have you as a member. And so there's details on how you can do that, how you can join up. We have resources as well as recordings of our webinars. So our next webinar is going to be in 3 weeks' time on July the 30th on emergency management. We will make sure we get you good information on that so that you can join us then. It is the same time, 10:30 Central, and in general, the same format. Our goal is to provide you the opportunity to ask questions so we can discuss and share, very much trying to do this as a fireside chat type of thing. Contact information. You've got me, you've got Nicole, you've got Eric, emails there. So please feel free to use those. And if you have an interest in a newsletter from me, there is a QR code, which I've fallen in love with QR codes. They are wonderful things. So,
They are great.
yeah. Please feel free to use that to sign up for the newsletter. Hopefully that's given you enough time there. We'll be doing, I would imagine, at least one follow-up email just to give you additional information where you can get all of this stuff from so that you can follow through on this. And really, all that is left to say is a big thank you for joining us this morning. I will go ahead and stop my sharing. And one last chance. Are there any questions out there that people would like to have answered?
Just to add to the confusion of emails, but just so you know, Eric is on the East Coast. I take care of the West Coast and mountain area. So if you're reaching out to us and want a specific location and we kind of know our accounts that are around our area, just reach out to us if you're within our time zone and area, I guess.
Excellent point. Okay. Well, thank you all very much. And with that, I'm going to say thank you to our two panelists, Nicole and Eric. Thank you to all our attendees for being here. And we will give you back a whole 4 minutes. We're ending 4 minutes early. There you go. That's time for a cup of coffee or something before your next meeting. So
Thanks,
with
Will.
that,
Thanks for having us.
hey, thank you for joining us. And